much as you actually think. Let logic take you the rest of the way. If you truly understand the meaning of hydrophobic, in science, if I have a black, I'm going to have a white. If I have a hot, I'm going to have a cold. If I have an up, I'm going to have a down. If I have a negative, I'm going to have a positive. There's always opposites, right? Acidic and basic, right? All right, so what's the opposite of being water-fearing? Water-liking. If something is not transported easily, then what's the opposite of not being transported easily in water?
Being easy.
Exactly. That's what hydrophilic is. It's just the opposite of hydrophobic. It's any substance that can easily be dissolved by water and is transported well by water. So if I memorize one and then say logically the other one is the opposite, you have less to worry about.
Other is transparent.
It also means you have control over the first definition. So let's just make sure we've got it. A hydrophilic substance is anything that can easily be dissolved by water or can easily be transported in water. Might be a little harder for you guys to give you an example of them. What is something that is easily dissolved by water? Easily.
Sugar.
Keep it simple. It's in your life every single day.
Sugar.
Salt, exactly, right? You take a teaspoon of salt, put it in a glass of water, yeah, you can see the salt falling to the bottom, but after you stir it, what happened to the salt?
It
It
disappears.
just disappeared, right? No, it got pulled apart by water, it got dissolved. You still have sodium, you still have chlorides in there, but now they're surrounded by water molecules. There's another rule of thumb you can do to guess if something is going to be hydrophobic or hydrophilic. Polar substances are hydrophilic. Polar substances are hydrophilic. So what are nonpolar substances? Right, and how do you know? Because it's the opposite of being the other one, right? If polar is hydrophilic, then nonpolar should be hydrophobic. Fats are nonpolar. I know fats are hydrophobic. Right? As much as you can, y'all, let logic take you the rest of the way. It's the best to memorize. Hydrophilic. We just talked about polarity, right? Polar versus nonpolar. We know that sodium can be polar and chlorides can be polar. But it's also how big the molecule or compound is. Anything over 6 carbons in size is going to have trouble dissolving. Anything over 6 carbons will have trouble dissolving. Are there more than 6 carbons in this thing?
Yeah.
Oh gosh, yes, right? I mean, look at it. You got 1, 2, 3, 4, 5, 6. Forget counting, you've got lots more, right? This is a fat. This is a fatty acid, all right? This you'll learn is cholesterol. And the cool thing is, in chemistry you learn about shorthand. Whenever 2 bonds come together, it's implied that there's a carbon atom there. So you've got 1, 2, 3, 4, 5, 6. Oh, double bond. 7, 8, 9, 10, 11, right? There's more than 6. So whatever that is, right, doesn't dissolve very well in water. These can dissolve or have a better chance of dissolving. Just some other examples of really big things, right? Here is a fatty acid. It's called saturated. We'll get these guys again later, right? Here's an unsaturated one. You're going to have a phospholipid. You have sterols like cholesterol. Do not memorize the structure. Do not memorize any of the names on here right now. We're going to revisit this slide later. Mainly water. In order for you to transport things from one part of your body to the next, it needs to be either easily dissolved and transported. If it's not, it needs to be made easily transported. And you'll have carrier molecules to do that with. All right. So how do I make these really big things? Here's the last little bit for today. Macro means big. Macromolecules. They are substances